dann würde ich sagen, machen wir mal weiter. Das ist natürlich jetzt ein bisschen die schwerste Session, weil irgendwie wir haben jetzt alle fantastisch gut und schwer gegessen. Aber deswegen haben wir auch eins meiner persönlichen Highlights jetzt gleich für hinters Mittagessen ausgewählt. Denn wir machen das jetzt schon ein paar Jahre und immer, wenn wir dann so im Programmkomitee zusammensitzen und überlegen, wie können wir denn jetzt eine hinreichend lehrreiche, aber auch unterhaltsame Konferenz zusammenbauen, dann gibt es immer so einen Content, den wir immer ganz gern dabei haben. Und das sind so Erfahrungsberichte oder wie es jetzt gleich so schön heißt, from the trenches. Und da waren wir sehr glücklich, als wir dann irgendwie die Einreichung von Stanislav und seinen Kollegen gesehen haben, weil genau das werden wir jetzt, glaube ich, ein bisschen kriegen. Also eine halbe Stunde geballte, praktische Erfahrung aus den Gräben. Stanislav.
Hallo zusammen. Also schönen Nachmittag, hallo zusammen, hello everybody. I will switch to English just to have again a change from our language landscape. Once English, once German. So I know it's a difficult role now because after very good eating we will have to talk about threat modeling, but I hope it will be easy for you to digest, first thing. And the second thing, we will make it a bit interactive, so we can ask some questions and some quiz questions and you can answer or raise your hand and participate in the session. A little bit about myself. I'm the presenter. We have authors who wrote those two slides, or all those slides, who are based in our other office in other country. And the slides here are mainly based on our practical experience from threat modeling projects. I work in Munich as a security consultant, mainly in application security, and maybe in the private life it will not help you always when you are skeptical and you see threats, but in security and application security it's of high value. So this helps also with threat modeling. And we will not spend much time on defining what is threat modeling because we want to relate it to practice and talk about what it is not and what can go better when you are performing threat modeling. And also here I can continue with what Christoph said in her first presentation. So threat modeling, we are trying to model the system and we want to see all the different components. We want to see how they communicate. We want to analyze them. And then we want to see what are the threat actors, what are the dangers or the threats, and then what kind of controls we have in them. And so you might think, okay, I have never done threat modeling, so it must be something difficult, I need more experience. However, I'm sure that most of you have done threat modeling, not maybe explicitly in your work, but maybe also in your life. If you want to cross the street and you see, is there a red light, are there cars coming, should I cross or should I wait? So we are also modeling the situation and the system. And here we will be focusing less on the theory. We will look at some design flaws which can occur when you perform threat modeling or when you forget to perform something from threat modeling. A design flaw, we have one example on the left side. It's not coming from my flat, but you can see there is a box and you cannot open it easily. And so this is not a security flaw, okay, very likely, but we have a second picture, and if you zoom with your eyes, you will see there is a barrier here, and you might have seen this picture already before, but you see there is a security control. Somebody should not be able to pass through, and still, because there is nothing around, and especially in winter, you can see how you can circumvent this kind of control. So design flow is something which is introduced earlier in the software development lifecycle, and here we have this 8, or let's call it endless 8, because it's an iterative process, and we start with planning, so in the middle, and we continue to the left, and then we go right again. And where should threat modeling be involved? Ideally, we should start as soon as possible and to able to save time and save costs and affect or influence decisions on our product or our application. However, we also might not be able to start at the very beginning because in the very beginning we will not have much to threat model. We need to have some kind of material, some kind of scope and something to be able to model. So ideally, it's the code and the build part where we can perform threat modeling. And from your experience, you might also know that threat modeling is also done sometimes during the deployment and operating phase, if it's a bit too late, or if something changes in the deployment version of the product. So. And now we will have our first three questions, so feel free to participate. The first one is, it's the client or it's just another internal team in your organization, and they say, I would like to perform a configuration review of our production environment. And we will just give you an access, and then can you provide us a report? Is this threat modeling or is it not threat modeling? What do you think? Who says yes? Okay, nobody. So everybody must say no. Yeah. Okay, so that's a good answer, and the answer is it's a configuration review, and it's something that could be part of threat modeling, but it's not threat modeling per se. It's a configuration review, and we are looking at the environment, and it's a different kind of let's say control or discipline. The second situation. We have already something to review, so it's good, and we are not in production yet, and so we don't have anybody from the team available, so we cannot perform any interviews, we cannot ask questions. However, we have some documentation from the old project, and could you check this old documentation, and based on this old documentation, could you perform threat modeling? So what do you think? Is it something that can be classified as threat modeling? Yeah, maybe. Could be. So could be, depends, yeah. Depends on the documentation and how much the new project has changed, because if the documentation is not relevant anymore, we still have to define the scope and see if it's something that applies to the new project. And then the third one, we have our first sprint in the very beginning, and we already want to think about security. So that's very good, because we are already invited to the table, so security. And we want to design secure password storage, and so the project owner wants us to have recommendations. So is this threat modeling or is it something else? Okay, some people are saying no, and that's correct. So we have no yes answer in these three questions. It's too early to perform threat modeling. If somebody asks you, okay, can you perform threat modeling for us? Then you would ask, okay, but is there something to be threat modeled? Is there something which is more or less stable, or something that I can ask questions about, or something that you have made your mind? Because if the client says, or if somebody says, I don't know how to do that, or I'm not sure, then it's difficult to make any judgment, because it's too early, it's very early. You can give recommendations, it's very good, but it's a bit too early for threat modeling. And now, in the remaining of this talk, we will have a couple of examples from our projects that we had with different clients. It's all anonymized, and we will be asking ourselves some questions. What went wrong? In the first example, we have this, we can call it a classical infrastructure, and we have a client who is connecting via reverse proxy, and there is an application server, then some log server which contains all the logs, and so we have a backend. So nothing surprising here. And what is given to us are a set of controls, security controls. So the first control, it's that they are using mutual TLS. It's very good, because that's not always commonly seen, but they have mutual TLS, so both clients and the server, they have to authenticate using their certificates. So that's a good control. Moreover, we also have XML signatures, and because it's a web service, we are using XML messages, and we are signing them, so nobody can tamper them. Also, we have encrypted log messages. That's even rare to be seen, but it's a good. They are signed and they are encrypted. And so if we take all these three controls here in theory, then we can say, okay, we have good encryption, and we are also safe against tampering or any integrity attacks. And now the question is, okay, is this enough, or do you see something that maybe could go wrong in this picture. So if you think of those three controls, think about how they work together. And the question is, if we go back to that slide, that's the hint, who sent the message? So the question here is, how do these three controls work together? How can we be sure that the client who has initiated the TLS connection is the same as some user on the application level who has signed the XML message, and if it's the same as the user who is in the log message? Is this somehow correlated? That would be the question. And the answer is that this was not correlated. So what could have happened in practice was that because we have different source of data, we could have this situation. The client connects as client A with a certificate, and then the message is signed as a different user. And then we could have potentially somebody else as a client C in the log message. And there was no correlation of these events or those controls. And so it would be difficult to say if it really works or not, or those controls. The lessons learned here are if we have more security controls, it doesn't necessarily mean that we are safer than if we have fewer of them. So it always depends on how they work together. So the system, we have systems which consist of many components and many security controls, and the question is, how do they work together? And then also we should not evaluate those controls in isolation and have a bigger picture. Also, when you are doing threat modeling, you are trying to not stay closed in your box. You are also trying to think about different interfaces which your system is talking to other systems. If you are threat modeling an environment, you also want to know, okay, what happens with the outside system? What's the trust boundary, and how do I communicate to other systems around the system I'm trying to model? And the controls that are introduced, they should not be in conflict. They should not be somehow omitting each other. They should be working together, which is sometimes difficult in security, but that is the idea here. And the last thing to say is it's not only important to protect the information against integrity attacks, or okay, it's all encrypted. It's also the question is who it is coming from, who is signing the message actually. Sometimes we see some developers saying, okay, we are using OAuth, that's great. We have also tokens, and then when you ask, okay, but who is signing them, who is creating them? Sometimes they might say, okay, we are actually signing them. So that's something which is not fully managed to a full extent. Okay, let's go to situation number 2. And this one, we have again our 4 systems here, and now we will be looking at passwords. We have a password storage, and a threat model was performed here. Because there are passwords stored in the plain text, we want to change that. And on the right side, you see this was then the secure change. So the passwords are stored securely using hashes, using salt. And now we have actually eliminated this finding here on the left. So now the passwords are stored securely. However, there was maybe a new sprint, and there was a requirement by one team called Fraud Department, and they said, we need access to plain text passwords because we have such use case, and we want to compare whether these are some, I don't know, known passwords that possibly come from a fraud activity. So how can we tackle this problem? And they said, we don't care where you store those passwords, just give us the plain text. And so the IT or the developers, they had to, again, work on the solution. And the solution was, okay, let's store those passwords in a session, in a user session. And here the idea was, okay, because it's only in the user session, after the session is gone, they would be removed. Those passwords would be removed, or they would not be valid anymore, and they couldn't be found anymore. And So then implementation looks like this. We have sessions, we have passwords stored in the session DB. And what's the problem here? So we have passwords which are now not stored in a cache anymore. They are on the session DB, stored really on a database, so persistently. Yeah. Yes. So we actually came a little bit up in our security, but then we fell down again, and it's even worse than what we had in the beginning. So exactly, that's a good point. And then, yeah, this is an example of a security control which or implementation flaw which was introduced. And what it tells us is, first of all, things might look good on the paper, but later, after the design is done, and when you have implementation and deployment, things can go a little bit in a different way. So when you are performing threat modeling, sometimes it's not known at the time when you are performing threat modeling, but the question is also how are you going to implement this security control and how is it going to be deployed? Because sometimes this can also introduce some new problems. When we are trying to fix one thing, we should think about not breaking another, not breaking something that has been done in the previous sprints that was working before and that will not be working anymore. And ideally, we should, as I said, we should have an overview of how this software is going to be deployed and integrated. And this is a little bit contradictory to what I said, that it's good to threat model from the beginning. But if you do it a bit later, the danger is that you will let's say, cover or uncover those risks later in the process. But on the other hand, you have more information on how it is going to be deployed and integrated in the environment. So you could also cover those phases. That's the advantage. We have example number 3, and this one is I guess easier than the previous 2 ones. So we'll have multi-factor authentication here for users who want to connect remotely. This could be a remote worker, this could be a client, somebody who wants to authenticate securely. And that's why we have a person, end user on the left side. We have authentication server. And then we have one-time password or one-time token server. So the authentication server is here for the passwords and validation of the passwords, and then we have one-time password server which validates the OTPs. Yeah. Okay, and then on the left side we have a database and some kind of storage, but this is not so important. So. Here in the red, it's an attacker, as you can judge by the color. It's red, so it's somebody who tries to attack, and the attacker tries to replay the captured credentials. And as we expect, because we have suggested to have some kind of validation, he will fail because these credentials, this OTP has already been used. So okay, the attacker cannot continue. However, let's imagine now you have to scale, because that's again something that comes later to the table. So first of all, you make some kind of threat modeling and you think about, okay, how it could work in theory, and then you have implementation, and you have to introduce load balancing, right? You don't want to have some availability issues if the user tries to connect and one OTP server is not available. So what you do, you introduce load balancer and you introduce more authentication servers and more OTP servers. And then you implement it into production, and then something could happen. So who wants to guess or who wants to say? What could have happened now? What kind of attack? Yeah, so exactly. So we have an issue here because we have 2 servers, and they are not necessarily or not at all synchronized. So that's something that was forgotten. I need to go closer. So what would have happened here is that we have a user who has logged in. However, an attacker has captured the credentials and also captured OTP. And now the attacker is lucky because the load balancer would use another authentication server. And here what happens is OTP server says yes because we haven't seen this instance yet. So your OTP is valid and you can log in. So this is what we need is a synchronization between those servers. And an example here is, again, we should think about how it will look out in the end, how it will look in the end, and look at if you have some kind of architecture diagram, it helps if it's not something that is, let's say, theoretical architecture diagram, but really how it's going to be deployed. And these kind of issues with synchronization and time attacks, they would then appear to be analyzed. And another message is threat modeling on one instance may be quite different from threat modeling when you have multiple systems. So that's something that you should you and we should not forget when we are doing threat modeling. It can also be sometimes quite difficult to actually model those situations when you have multiple systems and there could be some synchronization, time attacks. That could be a bit tricky, but it's something that should not be forgotten. Okay, then we go to secure connection open door. That's again a different example. And imagine you have a tracking solution. You have LKW, so a big car, or you have a bus, or you have elderly people, and you want to track where they are. You want to send information about their location, maybe some other data. Maybe if you have a car with a battery, you want to also send the information about the status of the battery. And imagine we have a product. It has a SIM card in it, and this product works with an access point, and this communicates then over secure tunnel, and there is TCP, IP, and IP version 4 or version 6, and it communicates with the infrastructure. So there is some kind of gateway, and there is a database, and there is a web interface for admins to log in and to manage those applications. And now when we think about attacking the system, where could we start, for example? What could we do? So we could try, as an attacker, try to attack the web interface. Yeah. We could also try to connect to the database. Most likely we would fail because we don't know the IP address, or we don't know how to get there. So the web interface we might be able to figure out, but it should be well protected from outside. We could also try and eavesdrop or somehow break the channel, but it's encrypted, so that would be difficult. We could also try to simulate APN, so this access point, and try to talk to the device with a SIM card. And the last option, or another option, would be to try to focus on the end device, so on the client device here. And we could try to maybe use a SIM card to speak to this device, or we could try to somehow download the firmware, maybe reverse engineer it, and so on. Okay, I was too fast, but so now let's imagine you want to act as a client. So what could you do? You could, as a threat modeler, not as a pen tester. So what you could do, you could ask, okay, how does this device work, and how does it communicate with this backend? And in this assessment, the assessors, without doing any pen test, without doing any reverse engineering, they asked the questions, the good questions, and they found out that there is no DNS involved in the communication, which means that we have IP addresses that are statically saved on this device. And so what could have happened if I managed to somehow compromise these clients? I would be able to see the IP addresses, and by seeing the IP address and owning the device, I could try to have to see all the firewall rules, so all the IP addresses, and then I could try to attack not only the device but also attack the data center, so all the systems. And this kind of attack is can can be classified as 22 or 202. So the 22 is the parent attack category, and it means that if we trust the clients and we do not, let's say, testify or verify the client, and the child category here, it's the create malicious client. So let's imagine we have a client, or we manage to get control of the client, and because the backend doesn't actually see that it's the user, it still thinks it's the system, it's the legitimate system that's talking to the server. And so the lessons here, the lessons learned here is we have multiple controls. If we have such system here, we need to take care of or pay attention to all the systems here. Not only the client system or not only the backend. We should take all the layers into account, because anywhere could be some lack of control. And we have the last one. That one is we'll do shortly. So we have user ID. Is it an asset or is it not an asset? What do you think? So who thinks user ID is not an asset? Okay, so everybody thinks it's an asset. That's very good. So in most cases, we want to protect asset. We want to protect user ID or username as an asset, because we have user enumeration attacks. We have other attacks, and if we manage to have the asset, we could do some kind of attacks, which we will show in the next slide. Let's imagine we have a gaming platform. Everybody can connect and play. And what do you want to do when you are playing? You want to have the highest score. And we have, this is the format of the username, not very difficult to guess. It's only 3 letters. And we have a Bob who wants to win at every prize. He wants to definitely be on the leaderboard. And so what he can do, he can perform a denial of service attack and just lock all those other users out, perform a lockout. And so nobody can play. They call the help desk, they complain, oh, my account doesn't work anymore, I'm logged out, and Bob is now the leader of the scoreboard. So here, this was just to give an example of an exercise that you do in the beginning of the threat modeling before you actually think about the risks. You want to identify assets. You want to identify things you want to protect. Not everything is an asset. Some things might be depending on the context of the project. And you also have to prioritize what assets are very critical, what assets are less critical. And based on this, you can then think about attacks and how you want to fix them and what kind of controls are there. In the summary, we can say that in threat modeling, we have some theoretical issues, but it's important to put it in the context of how it's going to be implemented, how it is going to be deployed. And let's also not underestimate having just a security control. It doesn't mean necessarily enough. The important thing is how you have implemented it and how it works together with other controls. And threat modeling is a nice exercise how you can uncover those risks without having any automated testing. It's mainly done using the interviews, or you look at the documentation, and it's a good way how we can uncover some risks which you would not always be able to see or uncover using automated testing or even manual testing. So threat modeling. Let's continue with threat modeling. And do you have any questions?
May I see the first question from our local threat modeling expert?
Hi, so thank you very much. I was wondering, when you work with your clients, what structured approach are you following, if at all? And what is the definition of done you give to your client? So how do you convince your client that you finished the process?
Did I finish the process? Okay. So the first question, the answer is depends. Depends, because there are some clients who say we already have our methodology, so we want you to follow that methodology, and we also have our methodology, so it's different. And really, I would say there are two approaches. You could first start with assets and then think about attack vectors and attacks. You could also use those attack trees to first think about different attacks and how they can develop, and think less about assets. And then using the component diagram, where you model the system, so using the components, using the interfaces, threat actors, and then thinking about the fixes, or what kind of controls are there, or which controls are not there. And for the threat modeling, if it is finished or not, it's because we have now a very iterative process of threat modeling, of a product lifecycle. It's never finished. It's always only up to certain points. And then what is good is to have some kind of iterative threat modeling. So each sprint you look at some kind of new features and you do some kind of light threat modeling. Okay, is this something relevant to maybe threat modeling? Is it something that we can ignore because this sprint does not introduce any features that are linked to security? That would be.
So one more question.
How does threat modeling work in a DevOps world, and who's responsible for the threat model?
Okay, thank you for this question. Ideally, threat modeling, the same as security, should not be a matter of security people. It should be ideally, if you have, let's say, a DevOps, you have a team of developers, architects, maybe just one type of role, and the product owner and the Scrum Master. So ideally, all of them should have a risk mindset, and there could be also somebody who has officially or unofficially the role of security champion, who is actually involved in the sprint and who sees all the stories, and somebody who can immediately say, okay, this is something security relevant. And in the DevOps world, threat modeling would not be something that we do officially now. Okay, now let's spend 1 week doing threat modeling. It has to be something light and scalable. And it can only be scalable when it's done by or think of by multiple persons in the team, and something which doesn't happen just now, but throughout the whole process.
Good. So let's thank the speaker again.
Thank you.